Hello and welcome to Slice of Physics. In previous videos we've talked about number maps and arrow maps, and in this video I'm going to talk about some connections between arrow maps and number maps. So before we had an example of a mountain, and this mountain was used to make a contour map, and we drew a contour map of the mountain like this. So what we're going to do now is we're going to make this into, so this was a number map, so we drew numbers around it, right? So we had turned this into a number map, and what we're going to do now is we're going to turn the number map into an arrow map. So then the arrow map is not going to contain any new information. It's just going to be another way of drawing this same number map. So what we're going to do is we're going to say that the difference in numbers between, let's say, this and this, we'll call that difference delta H for the change in height. So the height is the number in the number map. And the distance along the horizontal distance between these 2 points we'll call delta X. So if these points are here and here on the mountain, then this is delta H and this is delta X. And then we're going to talk about how quickly the height changes with delta X. So this is delta H divided by delta X, is how quickly the height is changing relative to delta X. It's like the slope of this mountain. So what we're going to do is we're going to draw some arrows. We're going to turn this into an arrow map. And the rules for the arrows will be, 1, that the arrows will be perpendicular to the contour lines, and 2, that the length of the arrow will be delta H over delta X. So what will these arrows look like? Well, it seems like the arrows should go in this direction, right? They should go out. And it looks like delta H between these two circles, these two contour lines, is 3. It goes from 6 to 3, 6 to 3, 6 to 3, 6 to 3. So delta H is always 3. And delta X, however, is different. So here, delta X is big, and here, delta X is small. So if delta X is small, that makes delta H over delta X be big. That means that these arrows should be big, where the contour lines are closer together, and these arrows should be much smaller. So, and over here we should draw some arrows. So the arrows are always perpendicular to the contour lines. There. And I don't know how to draw the arrows on this outward contour line because I don't know what delta X is to the next contour line, because there is no more contour lines. So now I've turned my contour map, which is a number map, into an arrow map. let's try that with another map. So here's another contour map. So I've drawn some contour lines and I've given them numbers. So nothing does, I'm always allowed to put negative numbers on my number maps. There's no rule against that. So I've made some lines with 0 and a line with 1 and 2 and 3, and I also made a -1, a -2, and a -3 line. So I could complete this number map and I could draw the 2's everywhere and I could draw the 3's everywhere, but I'm not going to do that. I'm just going to leave the lines. And now I'm going to follow this rule where the delta h over delta x is going to be the length of my arrow, and they're going to be perpendicular to the contour lines. And I'm also going to have the rule that they're going to go from the positive towards the negative contour lines. So here's an arrow, and it looks like all these arrows are going to be pointing down like that, from the positive to the negative. And then there's going to be, out here, there's going to be some short arrows, because the lines, the farther apart the contour lines are, the shorter the arrows are in my map. So there's going to be some really short ones, and then they're going to get longer and longer as they come out here, and then they're going to be short out here again. These are going to be some really short lines, and they're going to get longer as they come in here. And so on. So I can just draw my arrow map. So remember again, the rules are that when there's this large spacing between these lines, the arrows are short, and when they're close together, then the arrows get much longer. And the arrows are always going to point perpendicular to the lines, and they're always going to go from positive to negative. Okay, so now let's draw an arrow map that you may be more familiar with. So I'm going to draw a positive charge here, and we'll draw its arrow map, which is its electric field. So here's its electric field. It has big arrows here, and then it has smaller arrows out here. And then I'm going to take this arrow map, and I'm going to do what we just did in reverse. So I'm going to imagine, where should the contours be to match the system that we just used? So it seems like if the arrows are going to be perpendicular to the contours, then the contours must be circles like this. Also, it seems like the circles should be closer together wherever the arrows are long. So it seems like the circles should be close together here. They should be closer together towards the center, because the arrows are longer there. The electric field is stronger there. So the contour lines should be closer together towards the center. Out where the electric field arrows are shorter, it seems like the contours should be farther apart. So now we've just taken the electric field arrow map and we've turned it into a number map. So the arrow map here is called the electric field. And the number map, which is the contour lines, is called the electric potential. So this connection between the electric field and the electric potential is just the connection between arrow maps and number maps that we've been talking about. So the close together potential lines represent the strong electric field, and the far apart potential lines represent a weaker electric field. You can also tell from the potential lines what the electric field is, because you can also see the direction that it goes, right? The electric field always points perpendicular to the contour lines. So really these contour lines are just another representation of the electric field. They're just another way of looking at the electric field. That is another picture that we can draw to help us understand the electric field. But at this point there's no new information in this picture. This is just another way of drawing the electric field, only in terms of a number map or contour lines instead of an arrow map. So this connection is called the gradient. So we say that the electric field is the gradient of the electric potential. So when you have a number map like the electric potential, you can draw its gradient, which is its arrow map, that corresponds to it. And when you have the gradient arrow map, you should also be able to draw the number map that has that gradient. All right, thank you.